stream now so that I don't forget. So P-series were easy. I like that. So let's do a quiz. If the homework is easy, I got the quiz. So here's the quiz, but I'll, basically they're just P-series, and you just have to tell if they converge or diverge, and actually tell me the value of P. So the P from the P-series, so that you can, don't just guess, in other words. So basically you're going to have two things for each of these. One of them will be, does it converge or diverge? And then the other one is, what is the value of P? There's another one just for fun. There you go. There you are. There you go. Enjoy. There, another one. You want three? No, you just want one. I have three. Does everyone have one? All right, everyone's got one. Yeah, give it a go. This isn't going to take too long. Sorry. I didn't realize it would roll so quickly. Some sunshine. It's good. You're all set? You got a P for each one? Got something? Maybe? Got something. It'll be fun. Get that last one done. I know, the last one was a little bit funky, wasn't it? It was special. But we wanted to be invested. That's what we did very good. I'm not making you nervous, I'm just saying I'm just saying something. Oh, Lucas, you got something for me? What do you think? That's up for each one? So, nice. Yes, oh, you're good, really fancy. Yeah, well, you don't have to write all that. You're okay. It's okay. Well, you're sorry. Oh, we just have a button. Yeah, you see that? Oh my God. Yeah, you're doing it much better. Well, that's okay. You can continue it if you like. That makes sense now. Okay. I was so confused by what you were saying. What is that? The P-series. It's all P-series. You don't have to do the integral. But you did it, so you're okay. Integral works too. Integral test works. Converge,
So I was just watching the live stream. No, this is when you were watching the live stream because you're
watching the live stream.
I wanted
Is
to-
there such a thing? That's the problem with having this on YouTube and live streaming. I was worried this now half the class is going to go. Okay, I suppose that's a pretty good excuse. And now she's going to find out. There's also a lag, so about a minute from now, she'll hear us having this conversation.
Yeah.
Anyway, no, I'm not. It is okay. I understand, and it is better than nothing. I'm glad that you're here in spirit. Okay, well, let's go ahead and take a look at this one. So I didn't even write my answers because it is so quick. You could do the integral test, but the P-series test makes you, it's basically you've done the integral test once and for all for the P-series. So here the P is 1/2 because this is 2 over n to the 1/2 power. And 1/2 is less than 1, and so that will diverge. So the rule is welcome. Excellent. So you got here just in time to see the quiz. So anyway, when P is less than 1, less than or equal to 1, you diverge. So we're all done with that one. The next one, here P is 2, which is greater than 1, and so that one converges. This one was a little bit special, and I had this discussion with my Calc 1 students that whenever something is interesting to me, I should really avoid it, because you're not going to find it interesting or amusing. You're just going to find it hard. But this wasn't that hard, was it? There are actually 2 P-series here. So let me many of you did this without thinking of this as 2 separate P-series, and you're fine. But I just, it's actually technically 2. You have this one plus this one. 3 over n to the pi. So let's do these separately. This one, let's see, I guess I need to take this and rewrite it like this. 1 over n to the pi minus e. So if you move the e to the bottom, it's pi minus e. So that the p is pi minus e, which is actually less than 1. Pi is 3.14159. E is 2.71828. And so this number is, I don't know, 0.4 or something like that. But it's smaller than 1, and so that will diverge. And so it really doesn't matter what this is. This one would converge, but it doesn't matter because once you have something diverging, it's all going to diverge. So there it is. That's the whole thing. Hopefully it wasn't too strenuous, and I apologize for those who felt like they needed to compute the actual integral. But the integral test does work with all of these. It just takes a lot longer. Okay, let's move on. Can anything be bigger than infinity?
No.
Yeah, exactly. No, it can't. Well, yes, sort of, maybe. If you take advanced discrete math in the fall, you'll learn that there are certain things that can be bigger than infinity, but we're not dealing with them in here. So in here, the idea of infinity is sort of an upper limit. So this thing is this concept of growing without bound. And so whether you grow without bound like this, 1, 2, 3, 4, 5, ... That's growing without bound. This is also growing without bound. And for sure, every number down here is bigger than every number up here, but they both grow without bound, and they both end up at infinity. So it's not like this infinity down here is any bigger than the one at the top. The reason I bring this up is because if you have a series like this one that diverges, or that's actually a sequence that diverges, and you have another sequence that you know is bigger than that first sequence, then the second sequence is going to diverge as well. Let me see if I can give a better example of this. You know for sure that this series diverges. So n goes from 1 to infinity, diverges. So let's make this a little bit bigger. How could I make it a little bit bigger? I could do something like this, maybe. The sum where n equals 1 to infinity of 1 plus e to the negative n over n. So notice that my new series is just a little bit bigger. E to the negative n is just a small number. It's not very big at all. But I've just added this little tiny number to my original series. And so that's a little bit bigger, which means that this will also diverge. So here, I'll just write down the math that we're going to do. And I've got PowerPoint I'll show you in a minute. Once the iPad quits working, it quit working in the first class. So this is true. And so this means that this particular sum will be bigger than this sum. And so because the first sum is bigger than the other sum, then this one diverges, so this one must also diverge. The technicalities are a little bit more nuanced in this, but for all intents and purposes, you can pretty much do just that. You don't have to get any more complicated than that. Let me just close down this PowerPoint from classroom number 1 and find the one for this class. Here we are. Hold on a minute. All right. Yeah, I'm going to do it on the computer instead of the iPad, just so that I don't end up with, like, if it shuts down, we'll still be working here. Okay, so here's how you do the comparison tests. You take a series that looks similar to another series that you already know about. So in this case, this particular series should remind you of a series that you know converges or diverges. So does this series remind you of anything else? This gives me a chance to pull this little joyous app out. Oh, there we are. And find a person. Let's see, dismiss that. Calc2. All right, well, Sean. Sean, does that remind you of any series that you're familiar with? Okay, harmonic. So harmonic would be something like 1 over n. This is 1 over 2 to the n. So here's a good hint for you. So what does this remind you of?
The first letter.
What?
The first letter.
Well, no, just read this off.
1 over 2 and...
Oh yeah, 1 over 2 to the n. Very good. So this reminds you of a series that you're familiar with, this 1 over 2 to the n, and that's a series that you know either converges or diverges. So that's what we're going to compare this to. We're going to say, hey, that looks a lot like this series, 1 over 2 to the n. Now, you probably recognize that now that I've written it like that, right? And just say yes.
Yes.
Yeah, very good. Thank you. I knew that it would come to you eventually. So now that it's written like that, you're like, oh yeah, that is a series that I recognize. And in fact, let's just put you out of your misery. We'll move on to another person. How about Raylan? Raylan, what kind of series is this? Because you recognize it too, right? Maybe if I wrote it just a little bit differently, you might be able to recognize it like that. Does that look more familiar now? It's the same thing, right? So what kind of series is that? Geometric, yeah, and that you knew that it was, right?
Yeah,
You just were,
yes.
yeah, you just want to allow other people to guess. So we know that this either converges or diverges. We have the geometric series. We know the formula. So let's find out if you remember that. Briar, you know whether this converges or diverges, right?
Yeah.
Yeah, so what is it?
Yeah.
Yeah, very good. It converges. The 50-50 chance there, of course, but you knew it converged because it fits the geometric series sort of formula. And so how is it? So I know I'm just going around because I'm still a little bit worried, but Tony knows this. How does Briar know that this converges, or what's the rule?
The ratio of this and
Yeah, so this ratio, the common ratio is this 1/2 here, and the 1/2 has to be between -1 and +1 for it to converge. So this particular series converges because 1/2 is between -1/2 and +1/2. So this converges. We could compute what it converges to. Now let's compare this to what I have here. So here's the idea, is I have a series now I'm going to do the same thing that I just did, but this is no longer an infinite. It doesn't go to infinity. It doesn't diverge. This one converges. So here, let's do this. 1 over 2 to the n converges. To 1. So if you really want to know what this, you could do this yourselves. You remember the formula. Take the first term, divide it by 1 minus the common ratio. So in this case, the first term, n equals 1, is going to be 1/2. And the common ratio is 1/2, so 1/2 divided by 1 minus 1/2, it's 1. So that converges to 1. What about this? Now here's where we have to think about comparisons. Up here it was pretty easy to see that when I compare this to this, here's the comparison. 1 plus e to the negative n over n is bigger than 1 over n. What about these two though? What is the comparison between 1 over 2 to the n plus 1 and 1 over 2 to the n? Which one is bigger? Take a guess, and let's see if you're right. Pearson, do you have a guess?
I think 1 over 2 to the n is larger.
It is bigger. Do you have a reason, just out of curiosity?
1 over 2 is greater than 1 over 3.
Okay, that's a good way of looking at it. Very nice. So if you just plug the number 1 into both of these, you get 1 over 3 and 1 over 2. Yeah. That works for every number. If you plug any number in here for n, you'll always find that this is bigger than this. And the reason is that if you make a denominator bigger, it makes the fraction smaller. So I know this is going to be really, this is sort of weird, twisted thinking that you have to, it's hard for me too, I got to admit. Whenever I approach these, I have to think, okay, denominator is getting bigger, which means the fraction itself is getting smaller. Every single time I do this, I have to think through so don't fret if it takes a little bit to think through each one of these. So that's the case. So if this is the case, what this means is that this is smaller than this up here. So that means that this summation will be smaller than 1. So that converges. What does it converge to? I don't know. At least not yet. We'll get to that. There will be a point in time where we're going to care what it converges to. But for now, I just want to know whether something converges or diverges. Yeah, I'm hesitant. There is I could show you the end game, where we're heading with this. Because we're going to come back. You might wonder, where did we go? We're no longer in calculus land, are we? Like, what is this? Sequences and series. Well, I'll show you. I'll show you. I know, I'm a little bit worried about doing this, but I'm going to do it. There's a function. A calculus deals with functions, not this nasty stuff up here. It's a function. Okay, so here's where we're going in about 2 weeks, is we're going to find out that that function can be written as a series of x to the n over n factorial. And the reason why we care about this is because this function can be written like this, which means that if you do calculus with that function and you bump up against something that you can't do, sometimes you can do that calculus over here with this series and then translate back. So these series are useful tools for computing functions. By the way, just so that you know, you could do this. What is e to the first power? It turns out e to the first power using this series is 1 plus 1 plus 1 over 2 plus 1 over 6. I'm just doing the various factorials, 1 over 2 factorial, 1 over 3 factorial, 1 over 4 factorial, 1 over 5 factorial. I could keep going all day if you want me to. 1 over 6 factorial, 1 over 7 factorial. I think I'm getting sick of this, so I'm going to stop. But that's is approximately, I should say, because it's not exact. So there's e. is that number. Okay, so that's where we're heading with this. And there's other things you can do with calculus with series that you can't do with the actual function. But it takes a long time. It takes weeks. Literally. I mean, we've been doing this for over a week now, and we're going to be doing it for a couple more before we actually get to those functions. Okay, so I was hesitant. Hopefully that didn't confuse you. Let's get back to this. So here's the rule. Let's get back to the PowerPoint. Let's go on to this, whatever. Yeah, so our original series, whatever, it's less than, so this, it's going to converge. Okay, come on. Here it is. Here's the comparison test. Okay, suppose you have two series. I want to be able to blow it up. I almost went to my iPad and did the whole pinch and zoom, but it's small. Hopefully we can see it. So suppose that you have two series, and they are both positive. So this only works with series that have positive terms. So just bear that in mind. If this, let's see, if one of them is convergent and the other one is smaller than the one that is convergent, then the other one also converges. So that's what that first line says. And then the second one says that if one of them diverges and the other one happens to be bigger than the divergent series, then the other one diverges as well. All right, we'll come right back to this slide, but let's take a look at this. Give me a second. Sine squared in over okay, here we go. You're going to love this one. I know, you're looking at that thinking, oh, what joy, a sine squared. Okay, so let's take a look at this. And before we get any further, this is the series that I want to know, does this converge or diverge? I think you could probably take a guess at this point because you're already familiar with some of the series that you're dealing with. But let us compare this. What am I going to compare it to? So we have to make up something, and you have to make it up out of whole cloth. Well, not exactly. You're going to use this as a guide. What we want to do is we want to have something that looks a lot like what I have on the left, but is a series that I am familiar with, and I can easily determine whether it converges or diverges. For now, the two series that you're going to be using are either the geometric series or the p-series. So either use a geometric series or a p-series with this one. All right, so let's find a volunteer here. Haven, what do you think? What would you like to compare this to? And either you can tell me p-series or geometric series, or you can just tell me what the series is.
Would you go to like sine over?
Oh, no. I don't want any sines. None of those things have sines or cosines in them, do they? Sines and cosines are terrible. So get rid of the sine. What's left? What else is here that you can work with? I don't want a sine or a cosine.
Oh, would you do 1 over n squared?
Yeah, that's good. 1 over n squared, because that's a series that I'm familiar with. I know, it's kind of uncomfortable, because you're having to make this thing up. But you'll get used to this. You'll look at these things and you'll say, wait a minute, I don't like the sign there, but I like the n squared. And there's a reason why you like the n squared. In fact, let's take a look at that blue series. Let's push that red one away because that one scares me. But this blue series has a name. What do you think, Evan? What's the name? What would you call that blue series? That is not geometric. So what kind of series is it? It's the other one. Harmonic is a special case of what kind of series? It's the one that was on your quiz. The p-series, is that what you said?
Yes.
Okay, very good. So this is a p-series. Very nice. And so we know all about them. Look, you did this on your quiz perfectly. Well, almost perfectly. So this is a p-series. So if this is a p-series, I can tell you what p is. Lucas, what is the p for this p-series? P is 2, and so since p is 2, Sean, does this thing converge or diverge? It does converge because 2 is greater than 1. This converges. All right, so we know that this thing converges. Let's move ourselves back to this. So now I need to know, is sine squared of n over n squared bigger or smaller than 1 over n squared? So I need to know, do I put the alligator pointing left or right? Did you hear that, like elementary school? It always likes the bigger number, right? Okay, so which one? Which way does it go? Let's find out. So what do you think, Briar? Which way do I point this inequality?
Yes, the left.
The left? So the left is bigger than the right, you mean? Like this?
Yeah.
That's not right. So yeah, so think about it. The sine, so sine squared. Let me just, let's first of all graph. You know what sine looks like, don't you? Everyone knows what sine looks like. It looks like this. So this is y equals sine of x. And you'll notice that sine of x is always between -1 and +1. That gives you a little hint as to what sine squared looks like. Sine squared, because sine is always between negative and +1, when you square it, you're never getting a number bigger than 1. In fact, what it looks like is it looks sort of like this. But it's up there. It's always bigger than 0, always less than 1. So I guess what I'm getting at is that the sine is, if you compare the numerator here, sine of x is, sine of n, sine squared of n, sorry, is always less than or equal to 1. This is the same as this, and so the correct answer here is that this, pardon me, will be less than that. All right, we're almost done. So that means that this is going to be the case, that the summation on the left will be smaller than the one on the right. We know that the right one converges, so that means the left one must converge. Pardon me. Do I have anything left in here? It's tepid. It's terrible. All right. All right, so we're getting there. Maybe, let's see if we have some examples in the PowerPoint land. Okay, so we got this, blah, blah, blah. Okay, so yeah, just as a reminder, you'll either be comparing to a p-series, or you're going to compare to a geometric series. So just a quick reminder that those are the things that usually the go-to series that you're going to use. So let's try this one. Can you tell if this converges or diverges? Take a minute, write it down, decide what you're going to compare it to. I'm just writing it down here. All right, well, let's take a guess here. Julia, do you have any idea as to what you might compare this particular series to? There's one thing there that is kind of bothersome. If it wasn't there, that one thing, things would be so much nicer, wouldn't it? What's the one thing I'm thinking of? The one, yeah, the one. If we didn't have the one, things would be way better. In fact, yeah, let's get rid of the one. Oops. And so here's what you get. So this is Julia's series. There. That is a series that I can work with. I can't deal with the one on the left, but I can do the one on the right. In fact, I know what whether that converges or diverges. And you do too, I hope. You're not here to help, but you are. All right, Joseph. What do you think of this series? Let's move that over so we don't have to look at the one that we are eventually going to worry about. What kind of series is that?
Series.
What was that? I'm sorry, I didn't hear. GOP maybe, I thought maybe, I didn't hear you fully, and I thought maybe you had said, yeah, it's actually geometric, not geometric. So I don't know if you just mispronounced it, but yeah, I'm sure you knew that that was geometric. It might have helped if I had been so kind as to done this for you. How's that? Now it's obvious that it's geometric, right? Because you have a common ratio. You're multiplying by 2/3 for each of the terms. By the way, if you're not sure, geometric. If you're looking at that, thinking that that's a P series, let me know. We can go over that again. It's fine. Like here, in fact, let me just do it, just because I don't want you to be embarrassed. So here, this series is 2/3. Why can't I draw 2? 2/3 plus 4/9 plus 8/27 plus 16/81, and so on. So the common ratio is 2/3. Notice that you're multiplying by 2/3 each time. And then the sum is going to be the first term divided by 1 minus the common ratio. As long as the common ratio fits into a certain range of values, and you're not here to help, but Sydney is, does this converge? It does converge. Why does it converge? Less than 1, yeah. And also bigger than -1 if we want to be really. So I could compute the sum. In fact, I will. That's going to be 2/3 all over 1 minus 2/3, because it just so happens, just coincidentally, that the common ratio and the first term are the same. Not always the case, so don't always assume that. Anyway, that's going to be the sum. Okay, now we back up, so we know that this thing converges. Maybe since it converges, I'll just put a little smiley face on top of it. Converges. Okay, now we want to know what is the relationship between this and this. Do I put a less than or a greater than symbol in there? All right, Raylan, what do you think? Very good. The right is greater than the left. Can you, sort of explain? Yeah, this is one of those confusing things. And I always have to think through this. And that's why I had her explain, because I didn't know myself. But yeah, that's right. This denominator is a little bit bigger than this denominator. And when you have a fraction and you make the denominator bigger, then it makes the fraction smaller. So you can think of an example like 1/5 and 1/6. 1/6 is smaller than 1/5. So that might help to just have or 1/2 and 1/3. Those are easier. 1/2 is bigger than 1/3. 1/3 is smaller because the denominator is bigger. So this is the case. Now we have to make sure. Yeah, what do you think?
If the example was like different, so that the left was larger than the right, would it be divergent, or would we just not be able to tell yet?
You just don't know. Yeah. Because, yeah, so yeah, that's, okay, we'll take a look at an example of that right next. That's a great example. We'll get there. We'll get to Pearson's question. I love it. But here, for this one, yeah, so Pearson's question pretty much explains what this is going to happen, is that since this thing converges, in fact, we know what the sum is. It's right there. Since that thing converges, it means that this one here also converges. I don't know what it converges to. I do know that it converges to a number smaller than this, whatever that is, but it does converge. Okay, so let's deal with let's take a look at an example. What if I changed this? Hold on a minute. Yeah, this is great idea. Thank you, Pearson. So here, let's do this. Copy, paste. And I'm going to just make a quick change here to the denominator of this one so that I will thwart, so 3 to the n minus 1. There we go. now let's compare these two. So we already know about the one on the right. So if you were approaching this particular problem and you said, hey, that is really, it looks a lot like 2 to the n over 3 to the n. In fact, I'm going to do that as my comparison. Then what's going to happen is you're going to say, okay, 2 to the n over 3 to the n, that converges, and then you get down to this stage. And you say, okay, which one is bigger? And sadly, this one is bigger. Now I'm going to actually have to compute this number. So give me a sec here. So this is 2/3, all over 1 minus 2/3 is 1/3. Oh, that's just 2. Okay, so this equals 2. So all that tells me is that this is bigger than 2. Certainly it could diverge. Infinity is bigger than 2. But it might be that it converges to 3, because 3 is bigger than 2. Yeah, so that's one problem with this. Well, it's not a problem. It's just something to be aware of with this comparison test thing. There, let me just, whoops, there. That's what I want. Is notice that it says that if you have a convergent series and you have another series that's smaller, then you know that the other series converges. It doesn't say anything about what happens if the other series is bigger. So let me show you what to do if the other series is bigger. So when the other series is bigger, then you have to go back to the drawing board, sadly. So here's what happens is you go, oh, that one just didn't work out. So let's get rid of my smiley face, and let's find something else that we can compare this to. Okay, let's see, what can I compare this to? Hold on a sec. I want to make the denominator smaller, don't I? I'm having trouble. I picked a bad example, apparently. Yeah, this one is... Okay, how about this? 2 to the n, bear with me here for a minute, 2 to the n over 3 to the n over 2 plus 1 times 3 to the n over 2 minus 1. Okay, yeah, this is hard, I should say. Yeah, it's a lot easier to do this with p-series than with geometric series. So I'm just, yeah, I wasn't prepared to do this. But it is possible to come up with a different series. So you would come up with something else that would actually work. So I'll see if I can think of something, but I don't want to waste our time right now because we have a couple other things we have to deal with before leaving. So going back to here. Yeah, let's check this out. Okay, we've done that. We did this, blah, blah, blah. Oops, this one. Nope, not that one. This one. Here we are, thank you. Okay, so let's take a look at this one. Determine whether this series converges or diverges. I'll write this series down here. And this one, I will show you the example. This one's a lot easier to deal with if I change that plus to a minus. So it's just hard with the geometric series. I could do it, and I'll do it. 3, okay. All right, let's pick a person. And I think hopefully you're getting sort of a pattern here. In fact, I'll show you the pattern after we have Cheyenne tell us what she wants to compare this to. What do you want to compare this thing to, Cheyenne? So what does it remind you of? Does it remind you of a p-series or does it remind you of a geometric series? Yeah, let's compare this to a p-series. So let me give you the sort of the rule of thumb that usually works, but doesn't always work, as we just found out. But usually what you're going to do is you're just going to take the biggest term, whatever is the largest in the numerator. Oh, there's only one thing in the numerator, and that's a 5. and divide it by the biggest thing in the denominator, whatever's dominant. Like this is, so think of it this way, is that as you get bigger and bigger numbers, that is going to be so much bigger than 4n that you're just going to say, oh, might as well just be 2n squared. So that's what I'm going to compare it to. And this is the p-series that Cheyenne was hoping for. In fact, that's a p-series. We can say whether this converges or diverges. So let's go ahead and do this. Sarah, what is the p for this p-series? Yeah, it's just 2. Now, if it bothers you, if the 5/2 bothers you, here's what you could do. Just write this like this. There, now it looks a little bit more familiar. The 5/2 is just a constant. It can be factored out. But this p-series is p equals 2. Tony, what does that mean? Is this going to converge or diverge?
Converge.
Yes, and why does it converge?
Because p is greater than 1.
Very nice. So this thing converges. Beautiful. So this thing converges. Oops, why did I do that? I don't know. Here, I'll do this. Converges. Now I just have to ask myself, what is the comparison between these two? 5 over 2n squared plus 4n plus 3. How does that compare to this? Which one is bigger, and can you explain why? So I think you probably can with this one. This one's not bad. Owen, which of these two is bigger?
Go with 1 on the right.
On the right, and why is that?
Because you're only adding in the denominator the first one.
Yeah, so you're making the denominator over here bigger. On the left, it's bigger. So since the denominator is bigger, the fraction is smaller. So this is the direction this goes, which means this is the direction that will go, which means this will converge as well. Converge. Isn't that lovely? Okay, do we have, just a minute, do we have time for the, I mean, I could put a minus here. Yeah, let me just, let me put a minus here just to show you that you can do this with these. So let me take this thing, give me a sec. Since, yeah, so here we go. Come on, paste it in there. Okay, so let's just suppose that this was minus, minus. So when we did that, when we did this comparison up here, instead of having plus plus, it's minus minus, which means that this thing is actually bigger than a convergent. So the thing would go the other direction, the inequality. So in that case, we're going to have to think through, how do we make this smaller than a convergent series? It probably does converge, but how do we make it smaller than a convergent series? And so the way we make this thing smaller is we make the series itself bigger. So actually do the inequality first. So this is going to be 2n squared. Let's see, if I make the denominator smaller, minus, let's see, how about n squared? Is n squared bigger than 4n minus, plus 3? That's the big question. So is this true? Not always true, but it is true most of the time. So this will be true for, I know this one's not going to work out nicely, so my apologies. So n squared minus 4n minus 3 is greater than 0. That's what I would like to be the case. So this is going to be n, oh, it is going to, no, it's not. Okay, well, you could figure out what value of n. Let's just say this is going to be true for n greater than 10 for sure, because 100 is definitely bigger than 43. Oh, I have 5 minutes. Wait, do I have 5 or 10? 10 minutes, okay. Oh, but I have a meeting in 15 minutes. All right, let's wrap it up. Anyway, so because of that, because n squared is bigger than, for n greater than 10, you could just do this. N goes from 10 to infinity of the one on the left, and compare that with the sum where n goes from 10 to infinity of 5 over 2n squared minus n squared. That is a p-series. Specifically, it's just 5 over n squared. And it's also bigger than this series. And so because it's bigger, this one will also converge. And I know we're starting at 10, but think about it, we could start wherever we want, as long as this series, because it goes to infinity. So any finite number of terms, doesn't matter what they are. They're just going to be finite. All right, let me just do since I'm a little bit concerned about the homework, and I see that that's coming up, let us take a peek at what the homework is. It is on WebAssign. Once again, I still can't get away from WebAssign, at least for this section. So here, wow, so many. Number 9, let me just see what these look like. Determine whether it converges or diverges. It says limit comparison test. Limit comparison test. Just a minute. I may have to, okay, comparison test I can handle. Comparison test. Okay, so I will do a quick edit job here. I think most of these are going to be fine. It's just those last couple. So let me just do a quick edit. We'll edit out those limit comparison tests, and we'll do those on Friday. So we'll have to wrap this up on Friday. But let me edit this before you start it. I'll delete those 2 really quick, and then you'll be all set. So WebAssign for Friday. And don't forget the test coming up next Wednesday, a week from today. There will be a practice test available by Friday. So you can look forward to that. Also, take some stuff. It's getting a little heavy over there.